students, how are you? I hope you all are well. Today in this video, I am going to explain regarding refractive index. Refractive index and speed of light. This is just an extension of my previous video. In that video, just I gave the introduction of refraction of light. Then I explained about the laws of refraction and I used the term refractive index. So in this video, I shall make it clear what is the refractive index and what is its relationship with the speed of light. Let us see. So we know that light is refracted or bent. I can say that light is refracted or bent when it moves from one medium to another because of its change in speed. That means while light travels from one transparent medium to another transparent medium, at the interface it bends due to change in its speed, either slows down or speeds up. So the refractive index can be written as the ratio of a speed of light. So I can say that refractive index can be written as the ratio of speed of light in two media. Just you see. Suppose this is air medium. This is water medium. On light ray coming through the air medium, it incident obliquely on the surface of the water medium. There it starts bending. Instead of traveling straight, it bent because its speed changed. Now at this point of incident, I am drawing the normal. We know that this is angle of incident, this is angle of refraction. For example, the speed of light here it is V1. This is the speed of light in medium, in first medium 1. Here V2 is the speed of light in medium 2. Speed of light in medium 1 to the speed of light in medium 2. I have written V1 is the speed of light in medium 1, whereas the V2 I have written speed of light in medium 2. Then I can say that refractive index of medium 2 with respect to medium 1, or some books it may be written n/1. Refractive index of the second medium with respect to first medium, we can write it as speed of light in medium 1 to the speed of light in medium 2, or I can write that V1 upon V2. This is the refractive index of a second medium with respect to, I can write this is refractive index of second medium with respect to first medium. That means speed of the light in the first medium to the speed of the light in the second medium. Now I can say that, see here, suppose the first medium is vacuum. If the first medium is vacuum, then the refractive index is called absolute refractive index. Listen carefully. If the first medium is vacuum, then we say it is absolute refractive index. Simply I have written the N. Here no need to mention the first medium. That means I can write here N is equal to speed of light in vacuum to the speed of light in the medium. Here in place of a subscript, simply I am writing the N, which stands for the absolute refractive index. Okay, for absolute refractive index, no need to mention about the first medium. So since I shall not mention the first medium, here no need to mention about the 2. So I can write that absolute refractive index is equal to speed of light in vacuum to the speed of a light in the medium. Some cases, and we know that the speed of light in vacuum, speed of light in vacuum is equal to 2.9979 into 10 to the power 8 meter per second, and speed of light in air, it is 2.9970 into 10 to the power 8 meter per second. So this is almost equal. It is almost equal. So in place of vacuum, if it is air, then it is also called absolute refractive index. So I can say that since the speed of light in vacuum and air almost equal, so the refractive index of the medium with respect to air is also called absolute refractive index. Absolute refractive index does not require any subscript. Simply we write a, some books we also use mu. Okay, so this is about the refractive index and absolute refractive index. The absolute refractive index just called refractive index. Absolute refractive index is just called refractive index. Absolute refractive index is just called refractive index. That means the first medium is the either vacuum or air. Strictly speaking, absolute refractive index we use when the first medium is vacuum. But practically, since the speed of light in vacuum and air almost equal, that's why in the first medium air, then we say it is also absolute refractive index. But strictly speaking, absolute refractive index will be applicable 100% in the first medium is a vacuum. Okay, so practically either air or vacuum we use absolute refractive index, just we call it refractive index, and it is denoted by the symbol N or mu. Okay, here no need to write the subscript. Next one, suppose the medium is neither air or vacuum. If the first medium is neither air nor vacuum, then the refractive index is called relative refractive index. That means we say refractive index becomes relative refractive index. That means the first medium is neither air nor vacuum. For example, I am writing refractive index of glass with respect to water. Refractive index of the glass with respect to water. So I shall write speed of light in water to the speed of light in glass, or you can write this is relative refractive index, because here the first medium is neither air nor vacuum. So in this case we will use the term relative refractive index. So I can say that I can read it, refractive index of the glass with respect to water, or we can write in WG. Some books also mention like this. Both are accepted. Okay. Now just you see an example. The relationship between the speed of light and refractive index. Let us consider about the water. What is the refractive index of water? See that. Speed of light in water is equal to 2 into 10 to the power 8 meter per second. So speed of light in vacuum is equal to 3 into approximately 3 into 10 to the 8 meter per second. Then what about the refractive index of the glass? So refract index of the glass. Okay. So average glass I have taken. I have taken here water, speed of light in water. Okay. So speed of light in water is equal to speed of the light in vacuum, 3 into 10 to the power 8, and speed of the light in water, that is 2 into 10 to the power 8. Okay. So that means this is equal to 1.5. That means the refractive index of the water with respect to vacuum is 1.5. Here I mentioned only W because the first medium is the vacuum, that one no need to mention. So the refractive index of water is 1.5. The relationship between refractive index and speed is inversely proportional. When the speed increases, refractive index decreases, or speed decreases, refractive index increases. So whenever I said refractive index of water is 1.5, that means the ratio between speed of light in vacuum to the speed of the light in water is 1.5. So I can say that the relationship between refractive index and speed of light is inversely proportional, because n is equal to C by V. So n stands for refractive index, C stands for speed of light in vacuum. This is the speed of light in the medium whose refractive index we are going to find out. I hope that you might have understood it clearly. So this one also I can say that V1 upon V2 is also equal to N2 upon N1. Suppose this is the first medium, this is the second medium. If its refractive index is N1, its refractive index is N2. If its speed is V1 and speed is V2, I said that refractive index is inversely proportional to the speed of the light. So I can say that V1 upon V2 is equal to N2 upon N1. This is the relationship between refractive index and speed of light. I hope that you might have understood this concept clearly. Until the next video, bye.